Hi, my name is Anna Williams.
And I'm Eileen Crawford, and we had preparation questions part one, question two for lesson five. So, question two says, why does asexual reproduction give a twofold reproductive edge? For this one, we had a few ideas, so we're just going to talk about what we think the answer to this is.
The number one thing that we found for sure is that the edge that asexual gives on certain species is that you're able to have more young dealing with asexual because you're only dealing with one individual instead of two. Sexual, you are dealing with two different individuals, and so you would need a double fold just to replace the individuals that are reproducing.
Yeah, so basically it takes two to make one offspring. And then what we talked about too was how in each individual, they make four gametes that are haploid, and they have to combine them to make four individuals that are diploid. So you need two individuals to make four diploid organisms, where an asexual individual, you only need one individual to make four diploid organisms. So that's how that math works out. So that's for sure one of our answers. The second one that we talked about was how in some scenarios, not most and not all, asexual reproduction can produce more genetic variability within a population, not necessarily within individuals, but within the population. And that's based on the video that we had to watch in our overview and the notes from instructor, the nature article that we read. And it just talks about how in some situations you can, like, they give an example where there's a homozygous dominant individual who is tall, a homozygous recessive individual who is short, and then a heterozygous intermediate height individual, and predators prey on the intermediate height individual because it's easier to eat and it can't hide as easily as the short ones can. So what you end up with in the end is a bimodal distribution of tall and short individuals, and if they are to recombine their genes, they're going to have more intermediate individuals, which are just going to get preyed on again. So it's going to reach Hardy-Weinberg equilibrium again, where that wouldn't be very advantageous to that population. So in that situation, it would be better for them to reproduce asexually, and you would get more genetic variability within the population of tall and short individuals that would survive better.
Yeah, exactly. Some other examples that we found is that asexually, you don't have to energy into sexual displays, and also it saves from that predation when you're not displaying, because that's when a lot of species are vulnerable to predation, is when they're displaying. Sorry that the internet was kind of choppy in this video, but hope that you got something from it. Thanks for watching.